In our first video, we're going to talk about section 1.5, substitution method for integrations. So in this introduction videos, we want to know what is a substitution method and how is that coming from the chain rule. So let's quickly review the chain rule. So chain rule is talking about a composition function taking the derivative. So what is a composition function? When we have h of x, which is a function by combining the function f and the g, which is f of g of x. When we take the derivative, because we have an inner function and an outer function, so we have to considering them twice. So for the inner function, for the outer function, we're going to take the derivative and evaluate it at the original inner function. And then for the inner function, we're going to take the derivative by itself. In other words, we can talking about dy dx, which is dy du multiplied by du dx, where f is a function of u, and then u is a function of x. So let's do a quick example to review the chain rule. So for example, I want to find the derivative for h of x, which is equal to 1 over 3x squared plus 1 squared. So to take the derivative, we like to thinking as a power, because power rule is the easier one to work with. So we're going to rewrite it as 3x squared plus 1 to the negative 2 power. So we can see that there is an inner function, which is the 3x squared plus 1. And then we also have an outer function, which is something to the negative 2's power. So according to the chain rule, we are going to take the derivative of the outer one. So the outer one, which is a negative 2 power, which is negative 2 multiplied by something to the negative 2 minus 1. So this is the power rule. We just need to fill in what is the inner function, so we didn't do anything for the inside. We just copied it. Then we are going to take the derivative of the inner function. So let's use the red. The derivative of the inner function, which is 3x squared plus 1, which is 2 times 3x, or 3x to the first power. To combine everything and simplify it, we got negative 12x over 3x squared plus 1 to the third power on the denominator. So since we're not really focusing on the derivatives, so we're not going to go in details. But this is the chain rule. So you can see that when we have a chain rule, we always have an inner function and then the outer function. And then when we take the derivative, we will take the outer function and you doing whatever we want, but the inner function stay the same. And then we're going to multiply by the derivative of the inner function. And that is the concept for the substitutions. So it is really hard to thinking about both inner and outer at the same time when we're talking about the antiderivative, the integrations. So what we do is, since the inner function is going to be the u of x, we're just going to thinking about this is just going to be the traditional function where u of x is just one single variable. We're using the term u instead of a polynomial. And that is the substitution is coming from. So the substitution rule. The substitution rule says if we have u is equals to g of x, it is a differentiable function. and whose range is in the interval I, and then the function f is continuous, then when we try to find the integral of f of g of x times g prime of x dx, it is the same as finding the integral of f of u du, and that is the u substitution is coming from. Okay, so again, just really quickly, what we do is we figure out the inner function, which is g of x. We're going to replace it with a u, and because of that, let's use a different color. Because of that, this whole thing is going to be translated to du by taking the derivative of the u. Sometimes it's not going to be really straightforward. You need to do some algebraic simplifications to matching to the one you have, but in general speaking, the g prime dx is going to be matched to the du. So let's looking at one example. Let's find the the integration of x cubed cosine of x to the fourth plus 2 dx. First thing, you probably already see that we have a cosine function. This is a trig function. But normally when we have cosine, we just have cosine of x, cosine of theta. But here we have cosine of x to the fourth plus 2. So we know that the x to the fourth plus 2, it is the inner function. So this is a nice way to just let u be x to the fourth plus 2. Then let's take the derivative to find the du, which is 4x cubed dx. You can see that it is not exactly the same as we have for the original problem. We have x cubed. So we can do a simple algebraic expression by dividing everything by 4. So we got 1/4 du is equal to x cubed dx. Now x cubed dx can be replaced as 1/4 du, and then the x to the fourth plus 2 can be replaced by u. So this problem can be rewritten as integration of cosine of u multiplied by 1/4 du. We can put a 1/4 to the front. Now we have integral of cosine of u du, which is easy to integrate it, which is just sine of u, but we cannot using u because we're talking about the variable x. So now we're going to replace it back to 1/4 sine of x to the fourth plus 2, and don't forget the plus c for the constant. And this is the u substitution.